Hey everyone, in this video, I'm going to show you two things. I'm going to show you how to solve the empirical formula and the molecular formula. So for part one, let's start with the empirical formula. And here it's defined for you, and you can just write it on your paper. Empirical formula is the simplest form of a chemical formula. What this means is that the subscripts cannot be reduced or simplified. So let's go over some common examples. We have the first one, water, H2O. If we look at the subscripts of this chemical formula and we write them in the form of a ratio, we have 2 hydrogens to 1 oxygen. This ratio is simplified and can no longer be reduced. Therefore, we would consider it to be the empirical formula. Another example, CH2O. This one has 3 elements, but we can still write down the ratio of the elements in the compound. We have 1 carbon, we have 2 oxygens, and we have, 2 hydrogens and 1 oxygen. Again, if we take a look at the ratio of these elements, they are completely simplified. Now let's look at this one, C6H12O6. This is glucose, as some of you might recognize. If we write down the ratio of that one, 6, 12, 6, we can tell right away that this is not a simplified form because we can reduce this, and we reduce it to 1, 2, 1, same as the one that came right before it. So just remember that an empirical formula is when the subscripts are in their simplest form, and you can check that by writing down the ratios. Now, in a problem, I want to show you an easy way to remember how to find the empirical formula. So let's take a look at this little poem here. Percent to mass, mass to mole, divide by small, multiply till whole. Now you might think that this is kind of a cheesy little poem, but I guarantee you, if you memorize this, you're going to know exactly how to solve for empirical formula. The reason is because each line of this poem are the steps that you will need to do. So the first step is converting your percent to mass. If you remember, we've been working on percent composition. So percent composition tells you the percent of each element in the compound. So all we do is change that to mass. The second step is converting. We just convert the mass to mole using our conversion 1 mole equals the molar mass. And we've been working on that for the past few days. Our third step is divide by small. So we're going to take our smallest answer and divide. And our fourth step is multiply till whole. And those are the 4 steps that you'll need to find your empirical formula. Now I will say this, step 1 and step 4 sometimes won't be needed. But I'll show you that when we get closer. So let's go ahead and work number 1 on your paper. We're going to work that one together, and I'll show you how to use these 4 steps to get your final answer. So here we go. Number 1, it says, find the empirical formula for a compound which contains 32.8% chromium and 67.2% chlorine. So the first thing we're going to do is just make a list of the elements. So we have chromium and we have chlorine. So I'm going to go ahead and write my chemical symbols here. And I'm going to write their percentages. So I have 32.8% and I have 67.2% of chlorine. Now the first step right here, percent to mass. This is the easiest step because all you're going to do is drop the percent sign and put a G. So for chromium, we're going to have 32.8 grams. And chlorine, we're going to do the same thing, 67.2 grams. So we just did step 1, percent to mass. Now, if the mass is already given, we can skip that. But in this one, since it gave us percentages, we have to go ahead and do that. Now, step 2, mass to mole. This is where we use our conversion. Remember, 1 mole of any substance equals the molar or atomic mass, and we get that from the periodic table. So I'm going to put my multiplication sign here, and I'm going to set up my conversion factor. Remember, whatever you want to cancel has to go on the bottom. In this case, I want to cancel grams, so my molar mass, or in this case, my atomic mass, is going to go on the bottom, and my 1 mole is going to go on top. So if I look at my periodic table, the atomic mass for chromium is 51.996 grams, and that is in 1 mole of chromium. Okay, and I'm going to do the same thing down here to set up my conversion factor for chlorine. I look on the periodic table, and chlorine, the atomic mass, is 35.453, and that's grams in 1 mole of chlorine. So when I do that, if you notice, my grams cancel, leaving me with moles. And that's good because my step 2 says mass to mole. So now, remember, all you do is multiply across the top and divide by the bottom. When I do that, for chromium, I'm going to get 0.63 moles of chromium. And when I do that for chlorine, I'm going to get 1.89 moles of chlorine. Okay? So I just did step 2. Now step 2 will be required in all of these problems. Now step 3 says divide by small. So what I'm going to do is look at my 2 answers here. I have 0.63 moles of chromium, and I have 1.89 moles of chlorine. What I'm going to do is choose the smaller of the 2 and divide both of them by that value. So my small one is 0.63, so I'm going to divide both of them by 0.63. And when I do that, of course, anything divided by itself is going to give you 1, so here I have 1 mole of chromium. And when I divide 1.89 by 0.63, I'm going to get 3 moles. So I just did step 3. Now for step 4, for this particular problem, we don't have to do it because we already have whole numbers here. So if I take a look at this, I already have 1 mole of chromium and I have 3 moles of chlorine, so I'm ready at this point to put my final answer. So my empirical formula for this question is CrCl3. Cr, I only have 1 mole, and chlorine, I have 3 moles. So this is my empirical formula for this question. Now I want you to look ahead to number 2 and try to follow these steps and work number 2 by yourself. Go ahead and pause the video and try it. All right, let's see how you did. So number 2 says, what is the empirical formula for a compound which contains 0.0134 grams of iron, 0.00769 grams of sulfur, and 0.0115 grams of oxygen? So the first thing we're going to do is make a list of our elements. So we have iron, we have sulfur, and we have oxygen. So I know that my empirical formula is going to contain the simplest ratio of these three elements. Now, if we take a look at our steps here, step 1 is percent to mass. But since they gave me the mass already, guess what? I can skip step 1. I don't have to do that step. Now all I have to do is take the mass that is given and convert it into moles. So I'm going to start by writing what's given. 0.0134 grams of iron. I have 0.00769 grams of sulfur. And I have 0.0115 grams of oxygen. So I'm just going to do my conversion again from mass to mole. So I'm going to write my conversion factor for each one. And remember, since I want to cancel grams and get moles, I'm going to put my grams on the bottom and I'm going to put my mole on top. So I look on the periodic table. The atomic mass of iron is 55.845, and that's grams in 1 mole. If I look for sulfur, it's 32.066 grams in 1 mole. And if I look at oxygen, it's 15.999 grams in 1 mole. So again, my grams cancel, leaving me with moles. So when I do the math here, for iron, I'm going to get 2.4 times 10 to the negative 4 moles. When I do the math for sulfur, I'm going to get 2.4 times 10 to the negative 4 moles. And when I do the math for oxygen, I'm going to get 7.2 times 10 to the negative 4 moles. Okay? Now, I did step 2, so now I have to divide by small. Well, if I take a look at these, I have 2 that are the same, so it doesn't matter which one is my small one, so I'm just going to divide by the small one. 2.4 times 10 to the minus 4, and this is going to give us 1. Same thing with sulfur. 2.4 times 10 to the minus 4 is going to give me 1, and this is moles. 1 mole. And here for oxygen, if you can hear my dog barking in the background, I'm going to do 2.4 times 10 to the minus 4. And when I divide that, I get exactly 3 moles. Now, I did step 3. I already have whole numbers, 1 mole, 1 mole, 3 moles, so I don't have to do step 4. Okay, we don't have to do that step. Now, what we're ready to do is write our final answer. So all I do is take my ratio here. I have 1 mole of iron, so I'm going to do Fe. 1 mole of sulfur, so I'm just going to put S. And 3 moles of oxygen, so I'm going to do O3. And that is my empirical formula. Hope you got it. Now that we've got a pretty good handle on empirical formula, let's go to the next one, which is the molecular formula. The molecular formula is considered to be the true chemical formula for any compound. It is a multiple of a pre-existing empirical formula. So let's think back to an example that we did in part 1. Glucose, C6H12O6. If I look at the ratio, I can tell that it's not an empirical formula because the ratio of the subscripts is not in simplest form. But if I do reduce this, I can see that the common multiple here I can take a 6 out of all of these to change my ratio to 1 to 1. So now I'm going to take this ratio and show you the empirical formula where glucose comes from, CH2O. If I take this and I multiply it by my 6, guess what? I'm going to get back to glucose, C6H12O6. The reason is because my 6 will distribute. And this is a molecular formula. It is a multiple of a pre-existing empirical formula. So here I can see that when my subscripts are not simplified, such as here in glucose, that means that this is a molecular formula because it has a multiple, which we call the X factor. And that doesn't mean I'm going to sing for you, but I'm going to show you how to find that X factor so that we can find our molecular formula. When we find our molecular formula, we're going to start off pretty much the same as we did before by finding the empirical formula. So we're going to use our steps again: percent to mass, mass to mole, divide by small, multiply till whole. Remember that sometimes we won't use step 1 and step 4. Then find the molar mass of the empirical formula, which we will abbreviate EFM, and divide the given molar mass to get the X factor. Remember, that's what I talked about before. Now, the clue here is that whenever you're given a problem to solve for molecular formula, there will always be a given molar mass. And I'll show you that in these next few examples. So just remember, all we're going to do is find our empirical formula and do a couple more steps, and we'll be there. All right, so here we are for question number 3. It says, if 4.04 grams of nitrogen combine with 11.46 grams of oxygen to produce a compound with a molar mass of 1.52 grams per mole, what is the molecular formula of this compound? Now, real quick, just to point something out here, I want you to see that in this problem, the way that it was different is that here it gives you a molar mass. What this tells us is that the molecular formula that we're solving for has a different molar mass. So here we go. We're going to start off just the same with our little poem here. So we're going to write our elements. We have nitrogen and we have oxygen. And we can skip step 1 because the mass is already given. So we're going to go 4.04 grams of nitrogen and 11.46 grams of oxygen. And I want to convert this mass to moles. So I'm going to use my conversion, remembering that I want to cancel grams, so I'm going to put the atomic mass of nitrogen on the bottom. That is 14.007 grams in 1 mole. And here I'm going to go again for oxygen, canceling out the grams, 15.999 grams per 1 mole. So we can see that our grams cancel, leaving us with moles, which is exactly what we want. And when I do the math here, I'm going to get 0.288 moles of nitrogen, and I'm going to get 0.716 moles of oxygen. Okay, so what I just did was step 2. Now I go to step 3, divide by small. Well, I look at my two answers, And my nitrogen value is the smallest one, so I'm going to divide both of them by 0.288. Divide by 0.288. And here, of course, I'm going to get 1 mole. And here, I'm going to get 1.5 moles. Now, I did step 3. Okay? But what do you notice here that's different? Do I have a whole number right here? I don't. It's 1.5. So now I do have to go to step 4, which is multiply till whole. And all I'm going to do is multiply both of them by 2 to get a whole number. Now it's not always going to be multiplying by 2. Sometimes it'll be multiplying by 3 or 5. But whatever is the smallest number you can use to multiply to get a whole number, that's what you're going to do. So I'm going to multiply by 2. So here I'm going to get 2. And I'm going to multiply this one by 2 to get 3. So now I have whole numbers. And I completed step 4. Excuse me. And so I'm ready to write down my empirical formula. So I'm going to zoom us out a little bit to give us more space. So if I use this information to write down my empirical formula, I have 2 moles of nitrogen, so N2. And I have 3 moles of oxygen, so I'm going to go O3. So my ratio is 2 to 3, and that is in simplest form. Now, we've finished our first 4 steps for empirical formula. To do molecular formula, what I need to do is get the molar mass. So I need to find the molar mass of my empirical formula. So I'm calling that EFM, empirical formula mass. So when I add that all up, I'm going to add 2 nitrogens and 3 oxygens. So my empirical formula mass for this sample equals 76.011 grams per mole. Okay? Now remember that the molecular formula is a multiple of my empirical formula. So if I have my empirical formula, which is N2O3, and I know that I need to multiply that by something, I know that I'm going to multiply it by something, I need to know what this number is going to be. And the way that I do that is I take the mass of the sample given. So remember, over here I was given a molar mass. So I'm going to take my 152.0 and I'm going to divide it by my empirical formula mass. So my empirical formula mass was 76.011. And when I divide this, I get 2. When you divide this, you should get pretty close to a whole number. If you didn't, you need to go back and check your work. So what this means is that my X factor is 2. And remember, the molecular formula is a multiple, so this multiple is going to go here, and I'm going to multiply my empirical formula by a factor of 2. So when I do that, my molecular formula is going to be 2 times N2O3. Remember that this 2 is going to distribute to both of these. So when I distribute that and multiply, I'm going to get N4O6. Okay, that is my molecular formula. And notice that my ratio 4 to 6 is not in simplest form. And for our case here, that's good because our molecular formula is a multiple of our empirical formula. So now go ahead and pause the video and try to do number 4 by yourself, and then check back with me to see if you got the right answer. All right, let's see how we did. So number 4 says, a sample with a molar mass of 34 grams per mole is found to consist of 0.44 grams of hydrogen and 6.92 grams of oxygen. Find its molecular formula. So again, I just want to point out to you that the molar mass was given to us. So we know that we're going to use this later on to figure out our factor that we're going to multiply by, our X factor. So we're going to start off the same way, finding our empirical formula using our poem, percent to mass, mass to mole, divide by small, multiply till whole. And I can skip step 1 because the mass is already given. So hydrogen and oxygen, I have 0.44 grams of hydrogen, and I have 6.92 grams of oxygen. I want to do step 2, convert mass to moles. So I want my mass to cancel. So here for hydrogen, to set up my conversion factor, I'm going to put the atomic mass, 1.008 grams per 1 mole on top. And for oxygen, I'm going to put the atomic mass on the bottom, 15.999 grams in 1 mole. My grams cancel. When I do the math here, I'm going to get 0.44 moles of hydrogen. And here for oxygen, I'm going to get 0.43 moles. These are basically the same thing, so I'm just going to divide both by small. I'm sorry, that should be a 3. And it's going to give me the same answer anyway, 1 mole and 1 mole. So I did step 2, I did step 3. I don't have to do step 4 because I already have whole numbers. And so my empirical formula here is HO. Ho. That's what it is, HO. So remember, to find my molecular formula, I have to figure out what is the multiple I'm going to use to multiply my empirical formula. So let me zoom out here. So remember, the first thing I have to do here is find my empirical formula mass, which is going to be 17.007. And that's by adding 1 hydrogen and 1 oxygen. Okay, now I want to find my multiple. So what am I going to multiply by? I'm going to take my empirical formula mass, and I'm going to divide it into the molar mass that was given. So I'm going to do 34.00 grams per mole divided by 17.007 grams per mole, and when I do that, I get an X factor of 2. So remember, a molecular formula is a multiple of an empirical formula, and here I just found my multiple. So I'm going to take my empirical formula, HO, and I'm going to multiply it by a factor of 2. When I distribute, I'm going to get H2O2. Again, when I analyze the ratio of those subscripts, I can see that it's not in simplest form, which is okay. That is my molecular formula. I hope this video was helpful, and you guys need to keep working on the rest of the handout, the last 3 problems. The answers are posted on the board, so please check your work, and good luck.